Welcome back everyone to the Hello World guys. This is another episode of the Raycasting series, and in this video we are going to take a bit of a detour from our normal gameplay mechanics that we have been implementing. And in this video we are going to implement an important thing, which is dynamic window resizing. So currently up till now we had a window which could not be resized at all, and we had a window, so the size would be fixed at the start and then the size would remain like that, and we would not be able to change it during gameplay or any other thing. So that worked, but it would be better to have a window that can resize, and since our engine is actually not that complicated, it will not take a lot of effort to do it, so we won't actually have to consider too much about performance constraints. We could optimize because currently I have implemented it kind of as a very basic approach. We could optimize that, but it won't really be that necessary because it's not really some complicated engine. So first of all, I'm going to open up main.cpp, and in here we are going to just change our window, and we are going to not give it the additional flags, which will keep the flags at default, which means that the window will be resizable. So earlier on we were giving the title bar and the close button flags here, which meant that we had all of the functionalities except resizing, but now we are going to give no flags, which means we are going to give the default flags for the style of the window. And of course that means that this is going to be working, and we would have the resize button as well, and we would be of course able to maximize the window. So now let's go ahead and take a look at how the resizing will actually work. So the renderer is of course the main place where we need to make our changes. So the render class is actually now a lot shorter. So we don't actually have any of the screen texture or the Z buffer present inside the renderer. All of that will have to be created dynamically depending on the size of the window, and we don't have the constants here either because that would also depend on the size of the window. What we do have is that if I go up here, so you can see that in here we have removed actually render.cpp. So you can see in here we have also removed our camera Z and our the aspect ratio from const expression variables, because those are not const expression anymore. So let's take a look at our constructor. We are not constructing now the screen width and height and everything. We are not constructing any of that according to our like we were constructing the Z buffer and the screen texture. We are not gonna do that. So when we are drawing our 3D view, what we do is that we actually get our width and height as normal variables, and we get those from the target size. So whenever we are drawing to a render target, we get its size and we use that to get our width and height, and from that we calculate our aspect and our camera Z like we were doing earlier. Now for after this we have got some special logic which we'll need to do to make sure our sky is correct. So firstly you can see that now by the way in all of the places where we had the capital aspects, the actual const expression variable, now we've got our normal aspect variable, and similarly for the width and height. Now for the sky, what we do is first of all we calculate the aspect ratio of the sky texture by taking the sky's x, casting it to a float, and dividing that by the sky's y size, and then we get the sky width, which is just equal to our screen width. So the width of the sky will at all times be equal to our screen width, and the height of the sky will be equal to our height multiplied by our aspect divided by the sky aspect. Basically the sky height will be equal to the height of the screen multiplied by the ratio of the screen's aspect ratio to the sky's aspect ratio. And what that would mean is that our sky will be smaller or larger on the y-axis depending on what our aspect is, and that would mean that the sky will look correct from all aspects. However, what it does mean is that if our aspect ratio is too much portrait, so if the width is smaller quite a lot compared to the height, then some part of the sky will not be rendered at all, and we'll see a black portion there, and of course that is not desirable. And a way to fix that is to actually make our sky texture larger on the Y. So if it's 2 times as large, then it would basically not have the problem, but a more realistic solution would be to limit the aspect ratio. So we're gonna put a limit to the aspect ratio, because we don't want of course our game to be played in portrait mode, because of course this is not meant for portrait. Anyways, so when we are creating our sky, we use these sky height and sky width variables, and now instead of the static array of screen pixels that we had, now we have actually got a vector which is created dynamically depending on the size. And all of this dynamic allocation is a bit wasteful, doesn't actually matter that much considering that our engine is pretty simple, but we could optimize this a lot, and we probably should. And what you can do for that is that you can basically make a version of this inside of the render class. So we can make it inside of here, and in here we can store the width and height, and if the width and height changes, then we can reconstruct everything. So you can try to do that, implement that as an exercise, but for this for the purposes of this engine, I'm going to just leave it like this. So anyways, we do all of our code just like we were doing earlier, and now for rendering the screen buffer, we create a texture and we dynamically create it based on width and height, and we update it based on the data. Then we create a sprite with the buffer and we draw it. So yeah, that's very simple. So after this, we have got our Z buffer, which we create depending on, of course, based on our width. So we use that for our Z buffer, and then we have got basically all of the other code like we had pretty much the same way. And yeah, that's pretty much all we need to do as far as the renderer is concerned. Now there are a couple of things that we need to change, which are that in the game.cpp, when we are constructing our view, we need to kind of make it better. So earlier we were using the default view and we were positioning and changing that, which would not really work. So now what we are going to do is that when we are actually rendering this, instead of using the default view, we are going to calculate the center of the view. When we are rendering in 2D, of course, that's going to be the player's position multiplied by the grid size, and the size of the view is going to be equal to the window.getSize. Now for 2D, we are going to just create a view with this center and this size. And when we are doing it 3D, we of course want the center, the 0, point of the view to be at the top left corner. So what we do is we create a vector 2 called size, and we set it to just our window.getSize, cast it to a vector 2f, of course. And then when we are setting the view for the center, we actually use size by 2. So that would mean that the center position will be equal to half of the size, which means that the top left will be equal to 0. And then we are going to have size as the actual size of the view, and that would work correctly, and it would handle dynamically changing views as well. So that's pretty much it. However, there is a couple of there is just one issue here in the editor.h, which is that if I go here, you can see that we have got an SF view here which we are using, and if I go inside of this, you can see that when we do that, we might use the default. Well, actually we don't actually use the default view, so that doesn't matter, but we might have that a bit of a problem in editor. So let's actually try to run that and see if the editor gives us a problem. So if I press escape and go to the editor, and you can see that it actually works correctly. Regardless of our aspect ratio, I can maximize it, it still works. And I can go ahead and open up my normal view, and you can see that I can actually go around. I can change the size of this. The sky seems okay. You can see it's still alright, and I can shoot, of course, and this is kind of working correctly. So I'm going to go ahead and just close. Actually, let me just not maximize that. You can see that if I change the aspect ratio to be 2 portrait like this, then the sky kind of goes out of view. So we can adjust that by making the sky a little bit larger, and of course we don't want the game to be played like this, so we should probably just limit the aspect ratio. And another thing is that when we maximize our screen, our gun becomes way too small, so we need a way to adjust that as well. So these two things can be implemented fairly simply. So inside of game.cpp, you can see that we set the weapon scale to 2.5 and 2.5. Instead of setting it to just 2.5, we are going to actually go ahead and let's just go ahead and take our window size. So we are going to let's actually just do 2.5 multiplied by our window. Actually not 2.5 multiplied by, we are going to say SF vector 2f, and we are going to say 2.5 here and 2.5 here as well. But we are going to actually multiply this by our window.getSize .x, and we are going to divide that by say 960, which is our default window size. And what that would do, we would need to cast this to a float, I think. Yeah. So what this will do is that, or we can just divide it first. That would also work. Actually just put this in a bracket, and that would cast it automatically. So what this will do is that at the default size we will have this as 1 and the scale will be 2.5. As our size increases, the scale will increase too. So if I actually go and maximize, you can see that the gun still takes up basically the same amount of space, which means that it is working correctly. Of course, if I actually run this in maximize mode, you can see that the performance starts to suffer. So we will be looking into some optimization tricks soon, and I actually have a couple of interesting ideas regarding this. But well, you can see that for the basic purposes it is working in the normal mode. It's much more efficient, and of course the smaller the size, the better the speed. But regardless of that, you can see that now we can dynamically change the size of the window, and we still get our walls rendered correctly. Alright, so before we actually wrap this video up, we are going to go ahead and implement the size limiting inside of main.cpp. So in here you can see that we create our window and we can limit the size while listening for the resize event and then changing the size based on that. However, that is actually a problem on Linux because on the X11 Windows server, you shouldn't actually set the size of a window while the user is dragging it, and that if you do that, then that results in completely everything going wrong. So what we do is we do create two variables. One is should resize and one is just resized. And what we do here is that at the start of each event loop we set just resize to false. If we receive an event of resize, that means the user is resizing the window, we set the just resize to true. Now we get our aspect ratio by taking the event.size.width and dividing that by the event's height, which means what the new size of the window is. And if that is less than 1, which means that we are now in portrait mode, basically the height is greater than the width, then we set the should resize to true. Now in here we check if our should resize is true and we have not just resized, because if we have just resized, then doing it would cause problems, at least on Linux. So what we do is we go ahead and set the window size to basically the aspect ratio of 1. We have the same height, and for the width we actually have the height as well, which means that the aspect ratio is perfectly 1. And then we set our should resize to false. We of course, if the user is resizing, then we don't resize the window and the should resize stays true. So what we do is inside of this make, you can see that I can actually take my window back, and I can take it back quite a lot, and there's no really way to prevent this because because of the X11 Windows system. But as soon as I leave this, you can see it gets back to the correct value. And at the aspect ratio of 1, we actually have a perfect sky which is rendered correctly. Now if you actually want to have a sky that is rendered correctly even on aspect ratios lower than 1, then you will have to go ahead and change it so that the sky actually has a larger width, a larger height, and then the sky can be working even at smaller aspect ratios. But at our current, this works as long as the aspect ratio is at least 1, and you can see that this is actually working quite nicely. I can go around and change. If I try to reduce the size further than this, then leaving it actually snaps it back. So anyways guys, this is going to be pretty much it for this video. I'll see you in the next one, in which we are gonna go ahead and get back to our gameplay stuff. So stay tuned for that. Make sure to like and subscribe as well, and share this video with other people, and bye.